Hey guys, today we're going to go over a solution for question 4 on the AP Statistics Free Response Exam from 2019. Let's get started. Question 4 says that tumbleweed, commonly found in the western United States, is the dried structure of certain plants that are blown by the wind. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from the soil that would otherwise go to more beneficial plants. Now, all of that was really interesting, but none of that is going to be needed from this point forward in the question. So basically, we can take a look at that, read it, understand that it's important, but we don't need that part of the stem of the question. Scientists are concerned that these plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected plants were resistant. Now, here is the question that we're waiting for. Do the data provide convincing statistical evidence at the level of alpha equals 0.05 that there has been an increase in the proportion of all of the plants that are resistant? All right, so that means statistically significant evidence that we are talking about a hypothesis test. Remember, when we're taking a look at a hypothesis test, we need to check our assumptions, write our hypotheses, perform our calculations, and then write our conclusion. So we're looking for all of those pieces to be able to answer this question. So the very first thing we need to do are to check our assumptions. Now, we also need to know what type of test we're dealing with. We've got 2 years that we're looking for, and we're looking at whether or not there has been an increase in the proportion of plants. So this is a 2-sample test. It is a z-test because we're dealing with proportions, and it's a 2-sample z-test for a difference in population proportions. Now, we'll talk a little bit more when we do calculations as far as how we get credit for identifying the correct test, but if we're going to name it by name, we need to be really careful. All right, so it's important to take a look at our data too. So I'm going to write some data for 2014. In 2014, I know my p-hat, 14 we'll call it for 2014, is 0.197. That was the proportion of resistant plants. My sample size was 61. Now, I'm going to need to be able to calculate the number that were resistant. Remember, p-hat is the total number of resistant divided by the total. So 0.197 equals x over 61, and I'm actually going to have to calculate that x value, the number that were resistant in 2014, which is 12.017, but when I use my calculator to perform a 2-sample z-test, that needs to be a whole number, so approximately 12. I also need to take a look at the data for 2017. We'll call this p-hat 17.385. My sample size was 52, and again we can calculate our actual value, the number that were resistant in 2017, which is 20.02 or approximately 20. We're going to need that to be able to check our assumptions. So the first assumption we are going to check is we are going to assume and verify that we have random samples. Now, usually we can see that we've met that assumption in the stem of our question. So it says here, in 2017, randomly selected plants, and in 2014, we have randomly selected plants. So it's a valid assumption. But remember, there are 2 samples of randomly selected plants in 2014 and 2017 that are independent of one another. So my first assumption is I'm going to say that I have 2 independent random samples of these plants, and I might say in 2014 and 2017. Remember, in context. The second assumption is that I have to show that I have not sampled more than 10% of the population. So if I add, since these are both the same type of plants, I've got n equals 16 and n equals 52. If I add up 52 and 16, I've got a total sample size for both years of 113. So I can say the population of these plants is at least 1,130, showing that I have not sampled any more than 10% of the population. The last is I need to check whether or not it's reasonable to assume normality. When I have a difference in two sample proportions, I have to check N1 P1, N1 1 minus P1, N2 P2, and N2 1 minus P2. I actually have to verify these and find the actual calculations. So this is 61 times 0.197, which is 12.017. This is 61 times the remainder, 1 minus 0.197, which is 48.93. I've got 52 times 0.385, which gives me 20.02. And I've got 52 times 1 minus 0.385, which gives me 31.98. But what does all that mean? Since N1 P1, N1 1 minus P1, N2 P2, and N2 1 minus P2 are all at least, now these are all at least 10, some books say 5. You could say either 5 or 10. The distribution is approximately normal. Make sure we're not determining that it is exactly normal. We are saying it can be approximated by a normal distribution. So we have checked our assumptions. So that's one part of our score. One part of your score is the verification of these assumptions along with part of your calculation. All right, now let's take a look at writing our hypotheses. Our hypotheses, our null hypothesis is there's no different. So the proportion in year 2014 is equal to the proportion in 2017, or we could write that as the proportion, the difference, we could say P17 minus P14 is 0. There's no difference. Our alternative is what we're really trying to test. And so the final question asks us, has there been an increase in the proportion of plants that are resistant? Well, if there's been an increase, then that means the proportion in 2017 is greater than the proportion in 2014. So we could say P14 is less than P17, or P17 is greater than P14, or we could say if we subtracted P17 minus P14, if there's been an increase, that would be greater than 0. And then remember, that's not full credit yet. We have to write our hypotheses in terms of parameters, but we have to define those parameters clearly. So we have to say that P14 is the true or the population proportion of these plants resistant to glyphosate in 2014. And P17 is the true or population proportion of these plants that are resistant to glyphosate in 2017. Now, if you have all three parts where you've clearly defined your parameters and showed that they are population values, and you've written your null and your alternative hypothesis correctly, if you've got all of these pieces here, you would get an E on this section of this particular, oh, actually there's one more part. So let's take a look now at calculations. Now, in order to get credit for this part, the hypotheses and one part of the calculation, you have to clearly identify what type of test you're doing. If you only wrote a 2 proportion Z test, that would not get you full credit. You have to show that you're doing a 2 sample test for a difference in proportions. So you could write a 2 sample z-test for a difference in proportions. You could probably write a two-sample proportion z-test, or you can get credit for showing which test you're using by your test statistic calculation. Remember, it is your parameters, so it's going to be the difference in P14 and P17, whichever way that you're subtracting. So you could say P14 minus P17 minus statistic minus parameter, statistic minus my parameter, P14 minus P17, divided by the standard deviation of your statistic. Now, all of this I'm getting from my actual formula chart. So you're looking for the standard deviation of a difference in two sample proportions on your AP formula chart. So this is the square root of P14, 1 minus P14, over the sample size for the year 14, P17, 1 minus P17 over the sample size for 17. Now, if we go back and take a look at our null hypothesis, the null hypothesis said that this difference was 0. So this value goes to 0. So we can actually get full credit for naming the test by showing this calculation. The rest of our calculations, we can get credit by using our TI Inspire or TI 84 graphing calculator. So if we choose a two-sample z-test for proportions on our calculator, then we can enter the required values. Remember, that would be x14 was 12, n14, that sample size was 61, x17 was 20, and n17 was 52. If we do that, we get a z-test statistic of negative 2.20954. Depending on which way you enter, what you entered as x1 and what you entered as x2, the order that you entered those in, it could also be a positive test statistic. Now, remember, we're looking for, in this case, whether P14 is less than P17, or we could say whether P14, if we entered that first, minus P17 is less than 0 if we entered the P14 value first, which is what we did here. So that difference would be less than 0 for P14 to be less than P17. Well, our p-value that we get from our calculator is 0.013569. So the second piece of scoring here is verifying that you have the correct test statistic and the correct p-value, along with all of the correct assumptions to get that second part as an E. The final thing we need to do now is determine our conclusion. Now remember, your conclusion has two parts. It's the conclusion about the null hypothesis with your linkage or your reasoning and justification, and then your conclusion about the alternative. So the first piece, I would say, since the p-value is less than alpha equals 0.05, we reject the null. Now, that's telling me what we do in terms of the null hypothesis and giving me the linkage or the reason. That's one part of the conclusion I need to get a full E for this particular part of the question. Now, once I've rejected the null, so what I've really done is I've said there's no way the null is true, that gives me support in favor of the alternative. So we would say there is convincing statistical evidence of an increase in the proportion of all Kochia plants that are resistant to the herbicide. Make sure you're writing this answer in context. That's a second part, so we need to be talking about these plants, they're resistant. We need to talk about an increase in the proportion, and we've got evidence to support that. Be very careful. We are not determining that for sure there is an increase. We're saying our evidence does support that alternative hypothesis. So we've taken a look here at question 4 on the 2019 AP Statistics Free Response exam. Good luck in studying for this year's exam. Hang in there, guys.